Saxon Algebra 1, Lesson 78. We're tackling a topic today. We're going to add to this topic many times and come back to it over and over again. And I hate the name of it. It's called rational expressions. That sounds hard and complicated and just unpleasant and prickly. I don't like that. Here's what I like to call these: fractions with letters. That's the rational part. And the expression part, and no equal signs. Okay? That's what I call these. Fractions with letters and no equal signs. Let me give you an example. That makes them seem way more like friendly. Like they live in your neighborhood. There's something that you understand and know. Rational expression sounds like something out of Area 51. I don't know. I don't like the way it sounds. Oh, and these do, oh no, they're rational equations. I'm sorry. I read it wrong. Rational equations. So they do have equal signs. Yay. All right. Here comes a simple one. Okay, y over 2 plus 1/4 equals y over 6. All right, we notice this equal sign. And then we know right up there it says equations. That means that we don't have to just make the equation, the denominators rather, match. We can blow them up. We can get rid of them. So our step number 1, I don't know what that is to, I get violent about this, blow up the denominators. And the way that we do that is we find the least common multiple, just like we always have in the past, and then we multiply every term by the least common multiple. I'll let you write all that down. That sounds hard, and you know how it is. Words always make things sound worse than they are in math. Don't worry, it's easy, and it's kind of fun because we don't have to just make the denominators match. We get to absolutely eliminate them, destroy them, blow them up, kingdom the heck out of them. So, and the process is not hard. It's pretty familiar. So, the way that we do that is we find the least common multiple. In this example, 2, 4, and 6, the least common multiple is going to be 12, right? You probably just see that in your head. So what we're going to do is we're going to multiply every term by 12. Notice how I kind of write it at an angle like that? That's to remind me that what I'm doing here is I'm multiplying. All right. Now, the next step in this process is to cancel what we're multiplying by, the LCM, against our denominator. Now, we chose this number because we knew that every single one of our denominators is going to divide cleanly into it, right? So we know it's going to come out even, and I'll show you what we do with that number that's left. 12 divided by 2 cancels, and we're left with a 6. 6 now gets multiplied by the y. 12 and 4, that cancels. We get 3. 3 is multiplied times the 1. 12 and 6, those cancel. We're left with 2. 2 is multiplied by the y. So now what we've got left is 6y plus 3 equals 2y. Do you not feel so much better about that? I know I do. I know that I do. Now it's just algebra. It's easy from here, right? And it always will be. All right. I'm going to swim this 6y across, even though I know it's going to make an ugly negative number. That's fine. 3 equals minus 4y, and we'll divide by minus 4, and we'll get y equals negative 3 over 4. Yay. Not a horribly cute answer, but it works. All right, so blowing up those denominators was the only part of this that created much drama. And we know how to find LCMs, that's easy. Just making sure that we're careful here with our canceling. And then later, this will get a little bit more complicated, this process of multiplying whatever's in the numerator by the difference between those two, or the quotient, I guess would be the proper mathematical word. We just have to be careful at that step. But then from here on out, it's just algebra. It's fine. Let's do another one. There are 1, 2, 3, 4 in this lesson, and then we're done. Example 78.2. Ready? Two x over 7 minus 3x over 2 equals 1/3. Okay, a few letters thrown in, but we have equal signs. It is the equal signs, it's the equations that allow us to blow up the denominators completely. If you don't have an equal sign, you're going to be stuck with denominators in the end. But when you do have an equal sign, life is good and the denominators will be destroyed. Okay, so whenever you're looking at a problem with denominators and you're trying to figure out if you can make them go away, look for the equal sign. Okay, least common multiple. Now these numbers are still pretty easy, but I want to show you a trick. Well, no, never mind. This one's easy enough, we can do it. 7, 2, and 3, none of those go into each other, so we know that to find our least common multiple, we're just going to have to multiply them all together, aren't we? It's going to be 7 times 6, it's going to be 42. No way around it, because these are all prime. That's one way we know. These are all prime numbers, 7, 2, and 3. So we're not going to be able to find any pieces they have in common, like we did up here, right? These guys all had 2 in common. So we were able to find a number that didn't require us to multiply all of them together. Here, these are all prime. They don't share any factors in common, so we just have to go hard. All right, so now what we're going to do is multiply each one of these by 42. Okay, if you want, you can put the dot there. Another option that some students like to do is put parentheses around. After you get really established with this, I like parentheses, I think, in the beginning. Later, you can drop that when you're pro at this. But the parentheses just help you remember what the heck it is that you're doing up there. And I always write them at an angle, and that's the only thing I ever write that way. So that helps me remember, oh yeah, I must be multiplying by this to bust up those denominators. All right. 42 divided by 7 is 6. So now I'm going to write 6 times 2x. I'm going to put a line there so that I don't confuse my problem number with the problem itself. 42 and 2, that's 21. So it's going to be 21 times 3. You can see how leaving a little bit of white space in these problems is going to be helpful, because otherwise, it's getting really crowded. Okay. 42 into 3. Now, I don't know right off my head what that is, but I can easily figure out, well, it must be 7 times 2, right? Because 42 is 7 times 2 times 3. So if I'm dividing it by 3, it must be 14. And so I'll write times 14. I have a little more space going that way. Now I'm ready to look at my notes and figure out what I've got. 12x minus, 63x equals 14. Combine like terms. 12 and 63 are going in opposite directions, so I'm going to subtract 12 from 63, and then my answer is going to be negative. So that's what, 51? Negative 51x equals 14. All right, so what is going to go into both of these numbers Nothing. I'm just going to divide it by negative 51. 51 is 3 times 17, right? 21 and 30. Yes. But and these are both prime. 14 is 2 times 7. So these don't have any factors in common. So I can say that x equals minus 14 out of 51, and I know that can't be reduced because I examined the prime factors. Prime factors, you guys, are so useful for just breaking things down and canceling and making sure it's all lowest common denominator, and it's grateful for blowing numbers up because we can think about strategies there. Prime numbers are my friends, and I love them, and I hope you do too. Okay, that's our second answer. That's also correct. Yay! 78.3. I think John's going to make it a weensy bit harder in this one. Yes, just a weens. And we all know that a weens is not very much. It's microscopic. Well, this isn't microscopic, though. It's a little bigger than that. And as you write this, you'll probably see where the drama is. What's that? What's that numerator, John? That's a mess. That's going to be trickier. Okay, it's fine. We can deal with it. All right, I'm going to put this over a 1. Step 1, find the least common multiple. Well, this is going to be easy. It's just 2 times 7, so our least common multiple is 14. Now, notice that even though he doesn't have a denominator to blow up, we still have to multiply him by 14, because otherwise, Hannah Cranny's going to come and make a citizen's arrest. Right? So we have to multiply every term on both sides of the equation, whether they want it or not, whether they need it or not, it has to happen. All right, 14 and 2, that cancels to 7. So I'll multiply. Now look what I have to do here. As soon as I see it's a binomial, I wrap it in parentheses. 14 and 7 cancel to 2. 2 is going to have to be distributed across that. Okay, for now I'm just writing it on the outside. That's why I put the parentheses there, so I would distribute. But we can't just multiply the 2 times 8. It's got to be across the whole party of that numerator. All right, 14 and 1, there's nothing to cancel. 14 times 3, let's see, that's 30 plus 12, so that turns into a 42. I guess I didn't have to multiply it right away, but I did. Okay, ready? 21y plus, I'm going to distribute as I write this down, plus 16 minus 8y, right? Plus 2 times minus 4y equals, and I already did the work on that, 42. All right, I'm going to subtract 16 from both sides, and I'm going to combine these two. I'm going to do it all in one step. That's gone. 21 minus 8 is going to be what, 13y? Equals 26. John, thank you. We had 2 ugly fractions in a row, and I was worried about him. But now he made it cute. And we get y equals 2. Right? Blowing up the denominators is the whole work of these problems. Once we get that taken care of, we're fine. And again, the essential ingredient that allows us to completely eliminate the denominators is the equal sign. If we have an equal sign, we can do this because we're keeping it in balance across the equal sign. If we don't have an equal sign, we can't do this because then we're out of balance. There we have to go top to bottom, right, to keep it in balance. And that way we don't eliminate. So I will say that 600 times before our journey is over. But students struggled to strap into that distinction. So I'm going to keep reminding you. Okay, last one. 78.4. Solve. And look what he's doing to us now. 2 of our numerators have binomials. And now that we're experienced simplifiers with binomials, I'm just going to put the parentheses on right now so I don't even have to worry about forgetting because I know that's going to come. All right, let's build a least common multiple for these denominators. Here's what I like to do. Let's write them down as in their prime factors. 4 is 2 times 2. 2 is prime. It's just like that. And this is 5 times 2, right? So in order to find the least common multiple, I have to come up with the number that has the factors that include each one of these, right? So I'm going to need 2 2's. Okay, that's already represented. Here I've got the 2, but I'm going to need the 5. So that tells me that the least common multiple is 20, right? 4 times 5. Now, you could have looked at that and figured it out. I know that. I just wanted to show you so that if the numbers are ever harder or if you're brain dead and you just can't see that that's 20, I mean, it happens. You have a process for figuring it out. List the prime factors, fill your berry basket, and then calculate the number. Okay, beautiful. Now I'm going to gently squiggle this out. It was useful, but I don't need it anymore, and I don't want to confuse myself. Now I'm going to multiply every term by 20. Now I'm going to cancel top to bottom and multiply by what's left. 20 over 4 is 5. And I cross these out to make sure that I know I did it. 20 over 2 is 10. And then 20 over 10 is 2. And I'm putting it on the back end because I have a little more room. All right, ready? I will distribute 5x plus 5 minus 30 equals, and then I'm distributing this way, 4x minus 18. And now the hard part's all done, and we just have playful algebraic steps to go through. And that never hurt a flea, did it? Okay, let's combine. 5x minus 25 equals 4x minus 18. Let's swim the x's this way. And then we'll add the numbers that way. I'm going fast again. I'm sorry. I just get so excited. I can't help myself. Can't wait to see if it turns out to be an even number. That cancels. That cancels. 5x minus 4x is just plain x. Oh, I like when that just subtracts out because now I don't have to divide. Equals, let's see, minus 18 plus 25. That would be 7. And yay, that's the right answer. Thank you, John. You made it come out even. All right, so we did 4 problems. We worked ourselves up to doing these problems where there's binomials in the numerators. The secret is to put the parentheses around right away, and then that helps you remember that you have to distribute there. Here are the steps to blowing up the denominators. Make sure you have these written down. Step 2 is just, I mean, this is all that's new and different and exciting and fun. All right. Sorry I got that wrong. That's just sad, isn't it? But now you know it. We really were doing equations. Yay. And rational just means fractions with letters. So, yay. Okay, that's the end of 78. I'm going to stop talking now and return you to your normal life. Goodbye.